All right, here's chapter 6, handout that I gave out. Now let's take a look at this thing. What we've got is a carnival game, and you can earn points by throwing balls into a basket, right? So anyway, just to paraphrase, here we go. Here are the points available, and here's the probability that you get those points. And remember, we multiply, add them all together, and we get the average, which is 1.1, with a standard deviation of 0.0943. Now, it costs you $2 to play, and then you can get $1.50 for each point you earn. Okay, so they say let's define y as the new mean and the new standard deviation. So let's take a look at what that might look like. So u sub y is going to be, well, we earn $1.50, right? Multiply $1.50 times our old standard deviation, 1.1, but it costs us $2 to play. So that's going to be a negative 35 cents. So what does that mean? Well, over the long haul, if you play this game many, many times, you would average losing 35 cents if you average all of your games together. You know, sometimes you might win, sometimes you may lose, but you know, that's what an average is, right? Okay, now standard deviation. So the standard deviation, the new standard deviation of y would be the old standard deviation, which was 0.0943, and we're going to multiply that by 1.5. Do we subtract the 2? No, we never add or subtract when we're doing standard deviation. So let's see what that is. So the new standard deviation is going to be about 14 cents. So this game is pretty bad. You're going to lose most of the time, and you're going to vary not very much, by about 15 cents either way. So on average, you're probably going to lose a lot. Okay, so there's the first one. This one doesn't seem so bad. Let's see. You have all of these groups going up to check their homework, and you say, well, what's the combined times, right? So here are the average times for all of these different people, groups of 4, and the standard deviation. So if we combine them, all we have to do is add them together, okay? So let me do that. So the average time for all those groups to do this would be, and let's just say that's, the average, I'll just use C for the combined average, right? Not for Corey, but 4.5 minutes should be the average for all of them to check their homework. The standard deviation is a little bit harder, so the combined standard deviation is going to be 0.1 plus 0.4 plus 0.8 plus 0.7, square them all, add them together, and then take the square root. And that will be your new standard deviation. And the standard deviation turns out to be about, well, it is 1.14 minutes. Now, letter B says, suppose that Alan and Doug like to race to check their homework faster. What are the mean and standard deviations of the difference between their times? Alan and Doug. Okay, Alan and Doug. A couple of white guys. Let's see. Alan and Doug. Alan and Doug. Okay, and it's Alan minus, or no, Doug minus Alan. Okay, so what we're going to do is we are going to subtract. So how about we just say the new mean of, how about D minus A, right? That's our new average just for those two guys. Let's see, so it would be 1 minus 1.4, which is going to give you negative 0.4. Let's see. Oh, and so if we want to do the standard deviation of Doug minus Alan, and forget, we never subtract, right? We're still going to add those standard deviations. So the standard deviation for Doug was 0.7, square it, plus Alan, which is 0.1, square it, add them together, take the square root, get the new standard deviation, which should be 0.707. Okay, there you go. That's that one. Okay, two guys playing video games. Molsky, right here. So he has a mean of 110 minutes, standard deviation of 10 minutes. And then you got this other guy, Liberty, Mr. Liberty, and his time is 100 minutes, standard deviation of 8 minutes. Okay, so we are going to do, let's not forget that it's Molsky minus Liberty. Okay, so find the mean and standard deviation. So I might just do this, right? The new mean, which is what? M minus L, like that. It's just simply subtract the time. So let's see, 110, right? It's just subtraction. So dumb. And the difference between their times is going to, the average difference between the times is going to be 10 minutes. Now what about the standard deviation? So the standard deviation of Molsky minus Liberty. So don't forget, even though we're subtracting, we still have to add, and we're going to do what? It's going to be 10 minutes squared plus 8 minutes squared, and then take the square root. Let's find out what that is. And it should be standard deviation of about 12.8 minutes. Standard deviation is actually even higher than the average. Okay, so quite a big swing. Find the probability that Mr. Molsky will finish this game before Mr. Liberty on any given day. Okay. Okay, let's see. Let's do this probability problem here. The probability that Molsky will finish this game before Liberty. Now let's just think about this. If we take Molsky's time minus Liberty's time, right? Well, if they finish exactly at the same time, it's going to be 0, right? But if Liberty finishes after Molsky, he's going to have a higher time, right? So if Molsky finishes the game before Mr. Liberty, if we subtract them, it's going to be a number that's less than 0. Okay, so if we subtract their times, we want to say, what's the probability if we subtract their times? It's going to be a number that's less than 0. Well, z-score, here we go. Pretty sure we do this, right? The number that we're interested in is 0 minus the mean, which is 10, divided by the standard deviation, which is 12.8. Let's see what that z-score is. And I get a z-score of negative 0.78125. Let's just do negative 0.78. So negative 0.78. What do I do with that? Normal CDF, right? So here we are. We've normalized the graph here, and we're at negative 0.78. We want to say, what are all the numbers that are the probability that we're in this region, which is actually less than 0. That's what that tells us. So let's do normal CDF. So when I did that, normal CDF, lower bound like negative 100, upper bound is negative 0.78. That area under the curve is 0.217. So there's about a close to a 22% chance that Molsky will finish this game before Liberty. There you go. There's that one.